Well, welcome to RGES Algebra 2, Lesson 27, Part 2. We're continuing on with the lesson. This will be much shorter, but we're going to introduce the concepts for 8.6 when you're working on addition and subtraction of radicals. Now, just like when you cannot add or subtract fractions unless they have a common denominator, the cardinal rule with addition and subtraction, fundamentally you cannot add or subtract anything that isn't a like term. Okay, they have to be similar terms. So to be similar radicals, they have to have the same index and the same radicand. That means the same number in under the radical sign. So if I had 3, the square root of 10, plus 7, the square root of 10, I can combine these because they're both square roots, and they're both with a 10 in under the square root sign. So that would be 10, the square root of 10. If I had the cubed root of 8 plus the cubed root of 9, I could not add those. If I had the cubed root of 8 and the square root of 8, I could not add those. Okay, so they have to have both the same index and the same radicand. Now to do this, what you have to do is simplify each term. Now we know several ways we can simplify each term. If we have, for instance, the fourth root of 2 to the 5th, because I have 5 2's, I can take out 1, and I'm left with the fourth root with 1 staying under. I can also simplify a term by simplifying the indexes. If I had 6 of 5 to the 3rd, this and these can both divide by 2, so that can give, both divide by 3, and that gives me 6 divided by 3 is 2, so this is now the square root, and 3 divided by 3 is 1. So that's the same as the square root of 5. And the third way we know to simplify is if we had something in the denominator. Let's say I had the square root of 7 halves. I do not want to leave a radicand in the denominator, so that's the same as the square root of 7 over the square root of 2. I need 2 of these because it's a square root to be able to take it out from under, so I'd multiply this by the square root over the square root of 2 over the square root of 2. That gives me the square root of 14 over 2. And this is considered the simplified version. So we want to do all that kind of simplifying, and when we're done, if we get the terms with the same index and the same radicand, they can be added or subtracted. So I'm going to give you the same 2 examples that he gives you. This was in 8.6, and then I'll give you 4 more problems. Okay, so the first example is, I'm just going to be working down the left term, simplifying, and down the right term, simplifying. This left term, I need to take that 2 out of the denominator. So this becomes 6, the square root of 2 over 2. Because I need one more 2 in the denominator, and so I'd have to have a 2 in the numerator. And now that I have 2 in the denominator and taken the square, 1 can come forward. Okay? On this side, I'm going to rewrite anything I can in primes. And this is 2 to the 3rd power. On the next line, I'm going to simplify. I'm going to simplify by dividing here. This becomes 3, the square root of 2. This is a 6 for my index and a 3 for my exponent. So I'm going to divide both by 3. And this is the same as for the square root of 2. Now notice I have a square root of 2 and a square root of 2, so I can combine them, and that becomes 7, the square root of 2. Let's look at another example. Again, how I like to do these is I like to work the left hand and the right hand terms, each in succession, so that I'm going to rewrite 81 as a prime. That's 9 times 9, or 3 to the 4th power. I'm going to rewrite this as prime factored. This would be 2 times 12, which is 2 times 6, which is 2 times 3. On the left side, I can pull out 3 of these and be left with 1 underneath the radical, because it's a cubed root. And on the right side, I'm going to go ahead and write these with exponents. On the left side, I can't simplify anymore, so I'm just going to repeat that. On the right side, I can pull out, this is a square root, so I could pull out 2. And I'm going to be left with, under the radical, a 2 times 3. So I did make a mistake because I read this as a square. I forgot to write the index there in this term right here. So be real careful. So now I've got 3 of them, so I could pull out the 2, and I'm left with the cubed root of 3. Now notice what I have. I have the cubed root of 3 and the cubed root of 3. So I can now subtract these. This is 3 minus 2/3. Well, 3 minus 2/3 is 2 1/3, which is the same as 7/3, the cubed root of 3. Now I'd like to do some more. I'm going to go to the next page, and I'm going to do several of your problems for you. I'm going to do 1, 3, 5, and 7, because I think this is much easier to see this when you've seen several examples. The first thing you need to do here is you need to write this in prime factoring. So this will be the same as 2 to the 5th power. And this is the same as, if you did your tree or however else you wanted to do it, 2 to the 3rd times 3 squared. That'd be, let's say, 8 times 9. That'd be 72. Okay. Now, I'm going to simplify by taking out every group of 2. Then remember, just a square root sign is 2. So I've got 2 groups of 2, left with 1 under the radical. I've got a group of 2 and a group of 3, left with 1, 2 under the radical. Notice I have the same square root of 2, square root of 2, same radicand, same index. So 2 squared is 4. 2 times 3 is 6. They are similar, and so I can combine them with an addition or subtraction. 4 plus 6 is 10, square root of 2. Notice when I add or subtract, I'm not changing the part that's the radical. Let's look at number 3. This next one, I want to rewrite this as roots. This is the same as 2 to the 4th power times 3. Let's see, that would be 16 times 3. Yes, that works. Plus 18, the square root of 3 over 3. That's how I pull that up. Okay, why do I pull it up? Well, maybe that's not the best way I want to say it. I want to say I need, because this is a square root, I need 1 more 3 down there and 1 more 3 up there, right? multiplying by the same thing over itself is not changing the value. So now this below can come out from under the radical, and this stays in under the radical. See how that works? On the left side, I've got a square root, so I'm going to can take out two groups of 2, left with square root of 3. 18 divided by 3 is 6, square root of 3. I've got square root of 3, square root of 3, so I can combine them. 2 plus 6 is 8. Why do I have this wrong? I'm sorry. This is not 2. This is 4. 2 squared is 4. 4 plus 6 is 10, square root of 3. Let's look at another one, number 5. So what would I do? On the left side, I have to simplify by taking that out from under the radical, multiplying by the square root of 5 over the square root of 5. So this leaves me with 10 over 5 times the square root of 5. Right as prime factoring, 3 the 6th root of 5 to the 3rd. I can simplify this again, and I can simplify this. This becomes 2 the square root of 5 plus 3. Dividing both by 3, I get the square root of 5. Similar radicands, or similar radicals, and 2 plus 3 is 5. The square root of 5. Remember, we're not changing. Once we've identified them as similar radicals to add or subtract, you're not changing the radical. We'll do one more. I will simplify the left-hand term by writing it in primes. This happens to be 2 to the 7th power. I'm going to have to take this out of the denominator by multiplying the square root of 4 and the square root of 4. And so this becomes, the cubed root, not the square root. This becomes the cubed root of 4. The 1 times the 4 is 4. Over, I'm doing this wrong, I'm sorry. Let me pause on this. Not paying a lot of attention here, I'm sorry. Rewrite this. This is the same as the cubed root of 1 over the cubed root of 2 squared. So I have that's a cubed root. I have 2 of my 2's, but I need one more. So I'll multiply by the cubed root of 2 and the cubed root of 2. Okay, now I'll have 3 in all. Okay, so I can pull it out from the radical. Okay, so on the left side now, we'll divide 3. I have 2 groups of 3. Left with one more. On the right side, I'm pulling out my 2 from the denominator. I have 3 of them, and that's cubed root, so I can pull one group out. And on the numerator, combining, this becomes the cubed root of 2. I will simplify this. 2 squared is 4. 2. I will simplify this. I notice that I have the cubed root of 2 and the cubed root of 2. So I have similar radicals, so I can add or subtract them, and 4 minus 3 equals 1 of those. Notice I do not change the radical. So that gives you several examples. So I want you to do for homework, you're going to do 8.6. I've done several of these for you, but that's all right. Do them again. 1 through 22 all, and 32 and 33, which are the word problems. So do that. That's all I want you to do for homework. Just that one section, because this stuff is getting a little more challenging, and I want you to really think it through. Okay? Show your steps just like I do. Don't do a bunch of stuff in your head. Go ahead and do it on paper. Now, every Tuesday and Thursday, someone will be at Hoffmantown Portable D from 8:30 to 10:30. And so when I have papers to return to you for math, or you have a test or a quiz to take, a test to take home and do, and then turn back, whatever needs to be done, those papers will be over there on Tuesday or Thursday, both days, okay? So right now I have some quizzes, not for your class, but so for some of the other classes, but go ahead, and anytime you need to pass things back and forth, know that you can do that on Thursday or Tuesday. In addition, don't forget that if you're struggling with a concept, you must text me so I can address it again. Okay, and have a wonderful day.